Good morning, students. Welcome back to science class on the chapter magnetic effects of electric current. Okay. In the previous class, we had discussed electromagnetic induction and the working of electric generator, okay, or AC generator. So today we will discuss DC generator. Okay. So DC means direct current. Okay, that is unidirectional. So here DC generator which generates current in only one direction, but which one DC generator, that is different, right? Okay, so graphically we can show that AC generator that current like this. Okay, so AC is not unidirectional because in AC current direction changes for your rotation. Okay, so suppose if we can show graphically that direct current. Okay, so direct current is like this. Okay, there is no change in there is no change in the direction of DC current. Okay, so AC current means alternating current and DC means direct current. Okay, see, to run all the electronic devices we use DC current only. Okay, but we will get supply from AC generator only, but later we will convert that AC current into DC current. For example, mobile. Okay, so to charge that mobile, you will connect to AC only. Okay, but for that mobile phone, we need to run that mobile. We need a direct current. Okay, so that charger, okay, that adapter. So in that adapter, which converts AC current into DC current. Suppose if you take a computer and a projector, CC camera, etc. Okay, so there are all the electronic devices are the basis to run all the electronic devices. We use direct current, but we will get the supply from AC current only. Then later we will convert AC current into DC current. Okay. Yes. So now we'll discuss DC generator. So here also DC generator. Here also it works on the principle of electromagnetic induction. Okay. Then now see this even this DC motors which converts mechanical energy into electrical energy. Okay. So first I will draw the diagram. Yes, see here. Here this term DC. Okay, this is the first rotation. This is half rotation. Okay, later on. Now, so even this is also, it works on the principle of electromagnetic induction. Okay. Now just here, see here, these two are in north and so these two are permanent magnets. This is a coil. Okay, EBCD. So here this A side which is connected to ring R1 and R1 is connected to brush B1 that is connected to a circuit. So they want conductor. Next, this is CD side. Okay, this side which is connected to ring R2 and R2 is connected to B2. Okay, so this side this conductor is connected to B2. Okay, B1 and B2 are carbon brushes. R1 and R2 are, these are split rings. Okay, split rings. So here we need direct current, means what we need is that current in one direction, right? So that's why we are using split rings. Okay, so if you use those slip rings, then the direction changes. So we are using split rings. Okay, so that's why we will get direct current. Next, okay. See here also just we'll use the Fleming's right hand rule. Okay, already you know what is the Fleming's right hand rule. Okay, so you have to hold first three fingers of right hand mutually perpendicular to each other. Mutually perpendicular to each other. Okay, here the thumb represents the direction. Okay. See here, you have to hold these three fingers mutually perpendicular to each other. Here this thumb represents the direction of the coil or direction of the motion, and this forefinger represents the direction of the magnetic field, and the middle finger represents the direction of the current. Okay. Now see here, just imagine, see this is a coil A, B. Okay, so now I will go hold here. Okay, so now this is A, B, D, C. Now first just imagine I will rotate like this in this direction. I am rotating in this direction. Okay, yes, now it is thumb. Okay, which shows the direction of the movement. Okay, the direction of the motion. Now the coil is moving in this direction. Next, what about this one? Magnetic field direction, that is north to south. So here, direction of the motion, magnetic, and just release the middle finger. Just release the middle finger. Now, this middle finger showing the direction this side. So now the direction of the current is from this point to this point. That is from A to B. Okay. In the first rotation, the direction of the current is A to B. See here. Then A to B, C to D. Then the current goes from R2 to R1. R2 to R1. Okay. Yes. After half rotation, what will happen? After half rotation, so now this AB will come this side and CD this side. Okay. So here also, see, here we are rotating that coil in only in one direction, right? In even in AC generator also. But while we will get in, in AC generator the electric current direction changes. But here there is no change in the direction of the current. See here. Now, see here, this is CD here, CD. Okay, so now CD will rotate like this. Where we are rotating that coil in only one direction. Okay, so now it will move upwards. Yes, thumb. Then magnetic field direction, that is north to south. Okay, then current. Yes, current is in this direction. Now current move. The direction of current is from this point to this point. Okay, that is D to C. So now current direction is D to C to B to A to C, R2 to R1. In the first case also, the direction of the current is from R2 to R1 only. In the second case also, the direction of the current is R2 to R1. Okay, here there is no change in the direction of the current. Why? Because we are using split trains. Okay, so see here, this coil AB and CD side. See, in first rotation AB it will connect to R1, while half rotation, okay, then this AB is connected to ring R2. Okay, see, they will just imagine if it is a split rings, just these two are coils AB and CD. Okay, they will rotate like this. Okay, while rotating, so AB it will once it will contact with R1, then it will contact with R2. Even this is CD also. First rotation, it will contact with ring R2. After half rotation, then it is contact with R1. So that's why if you change that coil, okay, if you rotate that coil, at that time the current is generates from R2 to R1 only. Here also R2 to R1 only. So there is no change in the direction of the current. Okay, so we can they have told, so we can represent graphically this direct current like this. Okay, suppose what about AC current? But AC current, there we are using slip rings. Okay, there AB is connected to ring R1 only and CD is connected to R2 only. Okay, in AC generator, AB is connected to R1 and then CD is connected to R2 only. But here, this side AB, okay, and first it will contact with R1, then later it is contact with R2. But AB in the AC generator is not like this. Okay, AB is always connected with R1 and CD is always connected to R2. So that's why there the direction changes. Okay, but here there is no change in the direction. So this is the working of DC generator. Okay, so now here also how to increase the direct current. How to increase the direct current? One, so if you increase the speed of the rotation, if you rotate that coil with huge speed, and then so we'll get more current. Then if you use a powerful magnets, very powerful or strong magnets, so then also we can increase the direct current. So clear? So this is the working of direct current. Yes, next move to domestic electric currents. Domestic electric current.
See here, this is a schematic diagram of one of the common domestic circuits. Okay, so we use this kind of arrangement in buildings and homes everywhere. Okay, see here, you can see the two lines, right? You will get electric current, electric connection to your home from main lines. Okay, those lines only two lines. Okay, so out of those two lines, so one is live wire, another one is neutral wire. Okay, so this is a neutral, electrically it is a neutral, but that you are seeing that 220 voltage, everything is present in this live wire. Okay, next, see here, this is a fuse. Okay, already I have told right in the electricity chapter what is the importance of the fuse. Okay, actually this fuse is the electric circuit breaker, or we call it a safety device. Okay, why? Because you see here, these are these are conductors. For example, say fan, tube light, etc. These are okay. First, say you will get that connection from outside. First, you will connect this wire to first fuse only, not direct to your kind of gadgets or distribution box or meter. This is meter box. Okay, meter box. Okay. Hmm. Now, first you will connect this wire to one fuse. Why? Because see here, just imagine to run this device, they need say 220 voltage, maximum 220 voltage. Suppose if you pass 300 voltage, 300 voltage, at that time what will happen? So definitely we can say that it will burn, it burst. Okay? Why? Because due to excess voltage. See, it has a capacity to hold only 220 voltage. If you pass 300, then it won't work, it will blast. Okay? So that's why to avoid okay, to avoid for safety purpose, for safety purpose of that conductor, so here first we use fuse. Okay, even these fuses are made up of alloys. Already you know why the what is the importance of alloys. Okay, so alloys, they have high melting point. So now this fuse, okay, they will manufacture just to operate at 220 voltage, just to operate at 220 voltage. If the voltage excess, for example, say 300 voltage, so now 300 voltage it will come to in live wire. Okay, at that time what will happen is this fuse, okay, so this fuse which breaks and which melts. Okay, this fuse, there is one small wire. Okay, that is a light, it is made up of alloys. So that wire which melts and breaks the circuit, then there is no power supply to your home. Okay, then there is no power supply to these conductors or to the home. Okay, why? Because if the voltage is excess, if the voltage is very excess, means if voltage is greater than 220, then it melts. Okay, it will, due to the heat, what will happen? It melts. Okay, then the circuit, and then the circuit is open. At that time there is no voltage or there is no current to your home. Okay, so this is why the safety purpose, okay, the safety purpose of all these equipments, electric gadgets. Okay, electric gadgets. So first we'll connect the live wire to electric fuse. Okay, so that's why we call fuse is a safety device or a circuit breaker. If the voltage increases or excesses, then it melts and breaks the circuit. Okay. So yeah, then we'll pass to meter. You know how much energy you consumed. Okay, so we have to calculate that one, right? Because we have to pay money for the government. Okay, so we have to pay money for the government for their work. Okay, so everything is recorded. How much we have current is consumed, everything is recorded in the meter. Then from meter we pass to, we will connect to distribution box. Distribution box means, so we need a electric current for kitchen, bedroom, hall, everywhere, right? For all the rooms. Okay, so this is a distribution box. Then we'll directly connect to, for example, say fan, mixie, grinder, everything. Okay, and here see, you will get to see only two lines, one live wire and neutral wire. But you have seen in the socket board there are three holes, right? Three holes. One is very big and two small like this. Okay, so this one we call, that is earth wire. Okay, what is that? Earth wire. It means we use that wire for earthing purpose. Why? Because see, if even this is also for to avoid excess voltage, you know, this earth wire, okay, for example, just imagine you are using the what electric iron, okay, if you don't have earth wire, what will happen? So it gives a shocks for us, okay, we'll get a shock. Why? Because even our body is also conductor, okay, our blood, which is also 70% of good conductor, or 70 90%, okay. So if you use earth wire, what will happen? See, this earth wire, which is good conductor than our body, okay, this earth wire which is good conductor than our body, okay, if the voltage excess at that time, what will happen? If the voltage increases at that time, that voltage, it will pass through this earth wire, okay, it will pass through the ground. Clear? Why? Because this wire is it is which is a good conductor than our body, okay, so then we can avoid shock. Okay, if you want to use the earth wire, definitely we will get the shock while using these electric equipments. Okay, so here we are using earth. Why we are using earth wire? Just to avoid the shock. Okay, so here what happens? The excess voltage. Okay, excess voltage which is pass through this earth wire to ground. So clear? See here, in your home, don't try to join these two currents directly or these two wires. Okay, don't connect these two wires, live wire and neutral wire. You know, suppose if you take one wire, if you join these two holes, what will happen? We call it the short circuit. Okay, why? Because when you join these two wires, what will happen? The electrons, they will move sudden movement. Okay, that sudden movement, which creates more heat, okay, then blast. Okay, so that's why first here these two are connected, live and neutral are connected through what? These conductors. So here these conductors, they will reduce that flow. Okay, suppose if you connect these two directly, what will happen? There is a sudden movement of electrons from live wire to neutral wire, so which causes more heat and all the electrons they will burn. Okay, so that's why. So don't connect this live wire neutral wire directly. So clear? And one more. Okay, suppose you know if you have digital extension box. Okay, you have seen. Okay, extension box and here one button. You have seen, right? Okay. So here also, see here we have four options. We can connect the four gadgets here. Okay. For example, we can connect the mixer, AC, TV, computer, whatever it is. But we can't like that. Okay. So we can't use the AC, mixer, grinder, and everything here only. Why? Because see, if you connect all things, what will happen? That is overload. Okay, overload occurs. Okay, so here don't connect all the electric gadgets. For example, say fridge, mixer, and grinder, everything, all things to only one extension box. Okay, so don't connect like that. If you connect all the those gadgets, what will happen? So it causes the overloading. Okay. Yes, sir, successfully this chapter is also completed. Okay, in the next class we will start human eye and colorful world. Okay, thank you.